Welcome back to the OpenClaw Bootcamp. I am Adhiraj, and your agent at this point has a personality, has a voice, has boundaries, and for the first time actually sounds like someone you'd want to talk to. But here's the thing. Your agent still wakes up every session with no idea with what happened yesterday, doesn't know your preferences until you tell it again, doesn't remember decisions you made last week, and it can't connect the dots between conversations you had on Tuesday and what you're asking about on Friday. It has a personality but no continuity, and that's what makes the difference between an agent that's useful and one that's genuinely smart. Today, we're going to fix that. The memory markdown file is where your agent's long-term knowledge lives, durable facts, preferences, decisions, and context that accumulates over time and makes every future interaction better. This is the file that turns a capable agent into one that actually learns. Day 8, let's give it a brain. So on day 7, yesterday, you wrote a custom soul file with your own core truths, boundaries, and vibe. You tested it with a briefing request, an opinion question, and a boundary test. So today we're after 3 things. First, understanding the 3-file memory system, so the memory markdown file for long-term facts, daily notes for running context, and the dreams for automated promotion pipeline, because these 3 files can work together, and confusing them is how people end up with bloated context windows and surprise token costs. Second is knowing how hybrid search works and how memory is loaded versus retrieved on demand, because this is the mechanical distinction that determines what costs tokens and what doesn't. And then third, a curated memory markdown file that stays lean, avoids token bloat, and actually improves recall, because the docs are explicit that the memory can grow over time and can lead to unexpectedly high context usage if you're not paying attention. So memory in OpenClaw isn't one file, it's a system of 3, and understanding what each one does is the foundation for everything else today. The memory markdown file is your long-term memory, so durable facts, preferences, and decisions. This is the file that gets injected into the system prompt on every turn in private and DM sessions. It's always there, and your agent always sees it. And that's what makes it powerful, but also what makes it expensive if it grows too large. Then you have the daily notes at memory/the year, month, and day .markdown, 1 file per day, and these are fundamentally different because they're not injected into the context at all. They're accessed on demand via the memory search and memory get tools, which means that they don't count against your context window unless the model explicitly retrieves them. Daily notes are the running context and where the observations go. The stuff that might matter later, but doesn't need to be in every single interaction. Then there's the dreams.markdown file, which is experimental and optional. It's going to hold dream diary entries and dreaming sweep summaries for your review. It's part of the automated promotion system that moves important daily notes into long-term memory, which we're going to get to in a few slides. The key distinction here is cost. The memory markdown file costs tokens every turn because it's injected. Daily notes cost nothing until it's searched, and that's why keeping the memory matters, because everything in it hits in every interaction. Now let me make the loading mechanics concrete, because this is where the cost picture becomes really clear. The memory is a bootstrap file just like soul and agents, which means it gets injected into the system prompt on every turn. But it has a gate that the other bootstrap files just don't have. It only loads in private and DM sessions, not shared or group contexts. On session start, today and yesterday's daily notes are also read as one-shot start of context, but after that, first turn, they're only accessed on demand. The daily memory files are not part of the normal bootstrap context at all. They're only accessed on demand through memory search and memory get tools, so they don't count against the context window unless the model actually reads them. This is a critical design choice because it means that you can accumulate months of daily notes without any token cost until the agent actually needs to look something up. There's also the active memory plugin, which is an optional read-only sub-agent that runs before the main reply for eligible sessions. It uses memory search and memory get to retrieve relevant context automatically. It's going to return either summaries or none if nothing relevant was found. It's read-only. It can retrieve memory, but it can't write to it. One important architectural point from the docs is the model only remembers what gets saved to the disk. There's no hidden state. So if something isn't written to a file, it doesn't exist in memory. That's it. And for cross-channel memory, the memory markdown file is a single file on a disk shared across your entire agent. So DM sessions share one session by default. Same person contacts you from multiple channels. You can use session.identity links in your config to link their identities so they share one session with continuous memory. When your agent needs to find something in memory, whether it's like a daily note from 3 weeks ago or a fact that you stored in the memory markdown file, it uses hybrid search. And the way this works is pretty clever. Hybrid search combines 2 approaches. Vector similarity, which understands semantic meaning. So my preferred programming language matches I like TypeScript, even though the words are different. And then the BM25 keyword matching, which catches exact terms like IDs, code symbols, and proper nouns that semantic search might miss. The default weights are 0.7 for vector and 0.3 for BM25. And this balance means that most searches favor meaning over exact words, but still catch the specific identifiers that matter. If you have OpenAI, Gemini, Voyage, or Mistral key configured, the embedding provider is auto-detected and the memory search is enabled automatically. There's no manual setup needed. Now, there are 2 optional backends if you want more power. QMD is a local sidecar with re-ranking, query expansion, and the ability to index directories outside the workspace. Honcho is an AI-native cross-session memory system with user modeling, semantic search, and multi-agent awareness. For most users starting out, though, the built-in backend is plenty. You can also tune the search behavior through the config, so MMR diversity re-ranking is available, but off by default. And the temporal decay gives a recency boost with configurable half-life of 30 days by default. One nice detail is that the evergreen files like memory.markdown skip temporal decay directly, so your long-term facts don't get penalized just for being old. The agent has 2 dedicated tools for reading memory. So there's memory search, which does hybrid search across all the memory files and returns relevant chunks. Then memory get retrieves specific memory file or section by path. Both come from the active memory plugin, which defaults to memory core. Writing is different though. There's no dedicated memory tool. Instead, the agent uses a standard file writing capability, and writes are triggered by your own requests. Telling the agent, remember that I prefer TypeScript, you can write that to the appropriate file. Then there's memory flush, which is an automatic safety net that runs before compaction. When your conversation is approaching the context limit, and OpenClaw is about to summarize it through compaction, first runs a silent turn that reminds the agent to save important context to memory files. You can think of it like a silent agentic turn before auto-compaction to store durable memories. The flush config has enabled set to true by default, and the soft threshold tokens at 6,000, and the prompt it sends is literally write any lasting note to memory/the year month day .markdown. Reply with the exact silent token or reply if nothing to store. One more thing I want to note about the flush is it writes to daily files, not directly to the memory markdown file. The promotion from daily files into long-term memory is handled by the dreaming system, which is what we're going to cover next. Dreaming is how daily notes are getting promoted into long-term memory. It's a multi-phase scoring system that evaluates what's worth keeping permanently versus what was just context for one day. The light phase reads through daily files and the stages candidates. It identifies entries that look like they might be worth promoting, but never actually writes from memory.markdown, and so it only flags possibilities. The deep phase takes those candidates and then ranks them using 6 weighted scoring signals: relevance at 0.3, frequency at 0.24, query diversity at 0.15, and recency at 0.15, consolidation at 0.1, and conceptual richness at 0.06. To actually get promoted, a candidate has to pass threshold gates. So min score, min recall count, and min unique queries all need to be met. Only then does the deep phase write to memory.markdown. So the full flow here is you have conversations, important context gets written to daily notes, either by you asking the agent to remember something, or by the memory flush saving context before compaction. The light phase stages candidates from those daily notes, and the deep phase scores and gates them, and then the winners are going to land in memory.markdown as long-term memory. The dreams is going to hold the sweep summaries, so you can review what was promoted and why. This is super elegant because it means that memory.markdown isn't just a dumping ground, it's curated by a scoring system that prioritizes things that are actually relevant, frequently referenced, and recalled across diverse queries. Keep injected files concise, especially memory.markdown, which can grow over time and lead to unexpectedly high context usage and more frequent compaction. Here's why this is a bigger deal for memory than for Sol or even for agents. Those files are relatively static, so you write them once and you update them occasionally. Memory grows continuously. Every time the agent remembers something, every time dreaming promotes a daily note, the file is getting bigger. And since it's injected every turn, that growth compounds into a real token cost. The hard limits are the same as all Bootstrap files, so 20,000 characters per file before truncation through Bootstrap max chars, 150,000 total across Bootstrap files through Bootstrap total max chars, but really you shouldn't get anywhere near those limits. There's 4 curation strategies that actually matter here for you. First, you want to keep only durable facts inside your memory markdown file. So preferences, decisions, context that actually persists. Daily observations and running text belong in your daily files, not in the long-term memory. Second, let daily files do all the work. They're free until they're searched, so put running context there and only promote what proves durable over time. Third, you want to review that memory markdown file periodically, remove stale entries, consolidate those duplicates, and check your token usage with /context list in the chat. This is the absolute single most effective way to control memory-related token costs. Fourth, use the command line interface. So run OpenClaw memory status to check index health, OpenClaw memory search query to test what comes back, and OpenClaw memory index -- force to rebuild the index if something seems off. All right, 4 things before day 9. First, check your memory status. So run OpenClaw memory status to see your index provider, file count, and search readiness. If you have OpenAI or Gemini key configured, Hybrid search should be enabled automatically with no extra setup. Second, you want to store 3 facts conversationally. So tell your agent, remember that I prefer TypeScript, remember that I take meetings at Eastern time, and one more preference that is specific to you. Then start a new session and ask about those preferences. Verify that the agent's going to recall them from memory, not from your conversation history. Third off, you want to test memory search from the command line interface. So run OpenClaw memory search your query with both semantic query, like programming preferences, and a keyword query, like a specific name or ID. Feel the difference between the vector matching and the BM25 matching. The semantic query is going to find related concepts, and the keyword query finds exact terms. Fourth, you want to curate your memory markdown file. So open up your OpenClaw workspace memory.markdown and actually read what's in there. You want to remove anything stale, consolidate the entries that say the same thing differently, and then run context list in a chat session to see how much of your context window the memory markdown file is consuming. Congratulations, your agent now has a personality through the sole markdown file and continuity through the memory markdown file. It remembers your preferences, learns from conversations, and searches across weeks of notes to find the context that it needs. Day 9 is the agents file, which is the operating manual. Think personality and memory, but now a clear playbook for how to handle specific situations. That's tomorrow. If you want hands-on help setting any of this up, I do consulting at adirajhungle.com. And if this series is helping you, subscribe so you don't miss the next episode. I'll see you on day 9.